today we're going to study the frictional force between this box and the top of the desk. And we have a motion detector here, and we have a force probe here. And we will add different mass inside the box, so we'll change the weight of the box itself. We will use the Logger Pro software to record the force. And the first thing I'm going to do is to calibrate the force probe. First there's no force in the force probe, and I'm going to type in 0 and click keep. So the next thing, I'm going to hang 550 gram, and so in this case, the tension in the force probe equal to the weight of the hanging mass, and that's 5.3 Newton. So next I'm going to type in 5.3 Newton. Okay, so now the calibration is done. Let's do a quick check and see whether it's correct or not. So I'm going to click connect. So next I'm going to add this mass here. So this is the 5.3 Newton. Now if you look at the gram, that's roughly 5.3 gram. So our force probe is ready to use now. Next, I'm going to add this 500 gram inside the box, so that the total mass of the box will be the box itself plus this 500 gram. Next, I'm going to start collecting data, and first I'm going to click collect, and then I will start this one. So there are 3 parts for this experiment. First, I'm going to start part A. So I'm going to add 500 gram inside the box, and then I will use the force probe to pull this box here. And first, I'm going to start to collect, and let's see. Okay, so this is the data I collected. If you look at here, initially when there is no motion and the frictional force equal to 0, and there are 3 peaks here. This is the maximum static friction force, so we need to apply a large force to overcome the friction force to make the object start moving. But once the object start moving, so the force actually is smaller. So this will be the average. This will be the kinetic frictional force, and this peak corresponds to the maximum static frictional force. So next, let's see how to connect, how to get the data. So I'm going to highlight this part. And click stat. Now if you look at it here, the max 4.04 Newton, that's the maximum static frictional force. So let's repeat for other peak and stat. So now I have 2 data points, and then I can highlight the constant velocity part and click. And this time I'm going to look at the mean, the average. So this is the 1.99. This will be my kinetic frictional force. Again, I highlight this part. And so for this part, you see it looks like it's moving. It's the force getting increasing. It looks like it's fasting. So this is not a good data. I won't use this one. So I will do another trial and get another one. So next I'm going to try the part B experiment. We still have the box and with mass included, and this time no force probe, and I'm going to use the motion detector to detect motion. So I'm going to give this box a push so it will start moving, and then it will stop due to the static friction. So we're going to measure the acceleration in this case. Okay, so first I'm going to click collect and push, and now we have the graph. Okay, so you have this part, the speed is speeding up, this part slowing down, this part is the part that's only frictional force is acting, and this is the velocity time graph. So I'm going to click linear fate, and the slope of this line, this is the acceleration. So you can apply Newton's second law of this box. So only frictional force, kinetic friction force is acting on the box. So mass multiply this acceleration. This is another way to calculate the friction force. This is the this is the kinetic friction force between the box and the desk. So for this case, the acceleration is 4.79 meters per second. Okay, this is the setup for part C. I have some hanging mass over the pulley connected with the box, and there are some mass inside the box, and we have the motion detector to detect the motion, and it's connected with the Logger Pro, and I will analyze the velocity time graph to find the acceleration of this motion. So I don't want it to start moving now. I'm going to just use this one to stop the motion. Okay, so next I'm going to click collect, and then I'm going to remove this box. Okay. This is the result for part C. I have the position and the velocity graph. So this is the part the box start moving. So it's a parabola, it's accelerating. And this is the velocity graph. So you see velocity is constantly increasing. So to find the acceleration, I'm going to highlight the velocity and click linear fate. And this is the acceleration of this motion. So now we have the acceleration, and you have the mass of the box, and you have the hanging mass. So we can calculate the kinetic friction between the box and the desk during that motion.